So this video is going to talk you through some of the background information on the aspirin lab that we're going to be doing, and then get into a little bit of the procedure that we're going to be performing. So aspirin is considered an ester in terms of functional groups, but we are going to focus mostly on how it is made. So we're going to be looking at that. So aspirin is an organic compound. Okay, and again, if you want to highlight the things that I have highlighted here, that might be helpful. So aspirin is an organic compound. It's called salicylic acid, and I always say it wrong. It's made from salicylic. I always want to put an extra syllable in there. Salicylic acid, which is a pain reliever. It was found actually in willow tree bark, and it was used many years ago to relieve fever and pain. So ancient people knew its properties, knew that it would work effectively. But it has a very bitter taste, and it does irritate the stomach. So that is why a German chemist figured out a way to synthesize it and to make it less bitter, and so that people would actually take it. So for a long time, it has been used to reduce fevers, inflammation, and mild pain. But we now have other drugs out there that we can purchase, like acetaminophen, which is your Tylenol, ibuprofen, which is Advil, and we now have Aleve is another one that we have out there as well. So organic chemists are the ones that are in pharmaceutical production. They are the ones that develop the synthesis of these molecules, and they work with different research people and also physicians and nurses and all of those people to figure out a better way of making medicines, or medicines that we all need. So in this particular experiment, we're going to do what we call an esterification reaction. Again, in this class, we don't do much with the actual organic chemical reactions, but this is an acid catalyzed. So that means I'm going to be putting an acid into it in order to get the reaction to go a little bit faster. So it's going to be a reaction between acetic anhydride and salicylic acid. And so that is going to be what we call the active acid group. And then you're going to have an alcohol group that you're going to be looking at. So it is called a Fischer esterification, esterification. So if you do take organic chemistry, that is definitely a reaction that you will get to know. So this is our molecule of salicylic, and then this is the acetic anhydride. And so what happens is this H comes off, and you essentially attach this C double bond O CH3 to make the aspirin. So this is the aspirin molecule, and I will show you it again on the next page. And what you will see above the arrow is an H+. That is to show that you have a catalyst. And so your catalyst is some kind of acid. So we could skip the next page again. If you do take organic chemistry, that's what organic chemistry is all about. All of these reactions, and you need this to make this, and then this happens. So again, we're not going into that in this class. So instead, turn to this page. This has the reaction to make aspirin. So I do want you in your lab to actually take this reaction and put it into your lab, because I like you to see the reaction as often as possible. So this is a salicylic acid, acetic anhydride. Again, the H+ on top is going to be a couple drops of sulfuric acid to be our catalyst, and this makes our aspirin, and we do not care about this product. And aspirin does have a different name to it. It's called actic salicylic acid. I do realize that a lot of books have MW, which means molecular weight. We have been using molar mass. It means the same thing. Technically there is a difference, but if you do see that, That is what the reference is. These are, again, if I were to add up all of the carbons, hydrogens, and oxygens, that would be the mass. And then the one thing I did highlight here is this is the melting point of aspirin. It does have a different melting point than the salicylic acid. And so we are going to judge how well we make this aspirin by melting it and seeing if we get close to that 135, if we get close to that 135. Okay, so for our procedure, okay, we are going to be taking a hot plate and we're going to have a hot water bath. So again, this immersion heater and thing, that would be for something that you would put into the water to kind of heat it up. We're just going to use a hot plate. So we are going to place about 1.5 grams of salicylic acid, which is a white powder, and about 3 mils of acetic anhydride into a glass vial. I'm just kind of 1.5 in the amount, just because over the years I have found that you get a better production if we put a little bit more into that vial. And then we're going to add 5 drops of concentrated sulfuric acid to make it, for a catalyst, to make it acidified. We're going to put the cap on it, and then we're going to make sure it mixes, and then we're going to use a piece of copper wire, and you will see this in the video, to essentially hang the vial into the boiling water. Then you are going to create a ice water bath while this is cooking, essentially, into a 600 ml beaker with ice. And we're going to have a large test tube with about 20 mils of distilled water, cold distilled water, in there. And you will see why we need that. And we're going to cook this for a good 10 to 15 minutes. So in the procedure, it says about 10 minutes, but if I give you a window of like 10 to 15, we will definitely cook it for at least 10. We need to cook it for at least 10. Once you have cooked it for that period of time, you're going to place it on the counter for about a minute to cool so that you could touch it. Then you are going to essentially what we call isolate the product. So you are going to dump what is in that vial into that large test tube that is filled with distilled water. So literally there's going to be cold water in the test tube, and you're going to dump the vial into it. And then you're going to rinse it a couple times with cold distilled water to make sure you got everything out of the vial. You're going to then put the stopper on the top of the test tube and shake it, so it needs to have some agitation. And then you're going to put the test tube in the ice water bath for about 5 to 10 minutes. And this would be what we could accomplish on day 1. Then on day 2, we would actually try to filter out what we have created in the test tube in what we call a Bruckner funnel, which is also in the other video that you saw as reference. Once we have filtered it out, we are going to let it dry for a couple of days, and then we're going to do a couple of tests. One test that we can do is what we call a purity test, where we're going to put it in with a solution of iron 3. And the iron 3 is going to turn it a distinct color, a purple color if it is truly aspirin, and it won't be purple if it isn't. And then another day, we're going to do what we call the melting point. So we're actually going to take some of the solid and melt it. We're going to put it into a beaker of mineral oil, and we're going to heat it, and we're going to see what the actual melting point is of your aspirin. So that is basically the summary of this lab, and it is a good resource for you to answer some of the questions.